Okay, thank you. So my name is Rhea Doshi, and my invention is the CocoPure water filter designed to eliminate microplastics from our drinking water. Microplastics are plastic particles that are less than 5 millimeters in size, and they end up in our drinking water from various sources, including our clothes and cosmetics. They are invisible to the eye at less than 100 microns.
Hmm.
Ingested microplastics have been found in our blood, tissue, and now the fetus, and that is bound to have negative health effects. My solution focuses on using discarded coconut waste. 7.4 million tons of coconut waste is produced annually, and my invention upcycles this and turns it into a filter that is effective. So I started by creating a two-layer filter. The first layer is coconut husk, which is created by taking the coconut fibers, subjecting them to high heat and pressure, and it acts as a preliminary filter capturing the larger particles. The second layer is the activated charcoal, and due to its high surface area and many micropores, it's able to capture micro and nano-sized particles. So here's like a kind of just a model. So this is the coconut fibers, and this is the activated charcoal. My filter is effective, sustainable, affordable, biodegradable, and doesn't use any other plastic, unlike other filters on the market. Next, I got my first results by using particle count and image J analysis in order to count the plastic particles. I got between a 20% and a 90% decrease in microplastics depending on the size. Overall, I was able to achieve a 43.38% reduction rate, and this was with the single layer filter. From these results, I believe that adding more layers would be able to separate more microplastics. So one thing I want to bring to your attention is the big challenge that I've been facing. There's no set standard or equipment for measuring the microplastics, and because of this, I had to do a lot of testing. And so I developed two separate filters. So I have a cone and a cylinder, and I wanted to see which one is better. So I used infrared analysis. Though the cone was really fast and it absorbed less water, the cylinder is actually the better option because it was better at separating microplastics from water. So I believe that the secret ingredient to effective filtration is activated charcoal and its many micropores. The many micropores are able to capture a lot of micro and nano-sized particles via adsorption. Overall, my filter costs less than $1 to create, and it could be lower if only activated charcoal is used. One thing that I'm trying to figure out from this new data is how many times can the filter be used before it needs to be thrown out? And over here, I have images of the actual activated charcoal and the microplastics in the micropores. And so this was done using electron microscopy. And you can see the actual pieces of plastic here.
20 seconds left.
To conclude, I wanted to build a filter that could eliminate microplastics sustainably and affordably. My invention does that by utilizing the natural properties of coconut fibers and activated charcoal. For my next steps, I would like to do more testing to see how many times can the filter be used. Can the use of bioremediation, such as fungi and bacteria, be used to break down the plastics? And lastly, right now I'm working on understanding CRISPR-Cas9 and genetic technology to see if we can bioengineer a microorganism that can be used to break down microplastics in the body. Thank you for listening.
Great, thank you. Marcelo, do you want to kick us off this time?
Yep. So great project. And I'm glad to hear that you have no reference to measure the efficiency of your product. So you are the first one to think about that. That's great. And I'd like to know what's next. I've seen you have done some experiments, but are you thinking about to do a large scale of experiments with some kind of partnership with some company or some restaurant or something like that? School would be great.
So my next steps, what I'm trying to do is trying to get these filters actually implemented in every sink, in every home, every business, every school, every building, because microplastics is not just a local issue. It's not just like an issue in one country. Microplastics is an issue everywhere because of the amount of plastic every country produces each year. So my main focus is to getting these in homes and just in the faucets itself, so we can separate the microplastics on a larger scale. Also, what I want to focus on is getting these in the personal filtration systems that people have in their homes as well. I know I have one at home, and ironically, it's made of plastic, and it only adds to the issue. So that's like another thing I want to focus on is getting these in those home filtration systems. if I do want to scale, and I do plan on scaling this up even further past that, I would like to get it into those water filtration plants where, it goes through the plant and then comes to our faucets. I would like to get them implemented in those. And if it goes farther than that, I would like to implement it on those grates on the side of the road. Because if you didn't know, the road markings that are used to paint the road so that people have the lines actually contribute to microplastic count as well. So we could, so when the rain comes down, it gets mixed with the microplastics and goes into the grates and into the oceans. So I would like to stop it on that level as well.
Thank you.
Thank you.
Phil?
Yeah, so great work. I love the science. I'm a science nerd, so I like all the science stuff. So great job on that. But you're thinking big, but before you think big, you have to think very small.
Yes.
So your next step is you have to find who's going to be that first customer. Who's the person who has the biggest version of your problem, who would rip this solution right out of your hands if you showed it to them. So who might that be?
Well, definitely it's the consumer itself. It's the people, not even the government. It's the people who have the biggest problem with microplastics. These microplastics are getting into animal organisms. They're getting into our bodies. And I think the main thing is right now that a lot of people don't actually know about the issue of microplastics. They think it's so small that it can't really harm us. So the first step actually would be to educate people on the issue of microplastics. That's the first step, because even I just learned about microplastics rather recently too myself. It was reading an article out of National Geographic, and I bet a lot of people still don't know about this growing issue. So my first steps would be to get the people educated, get partnership with the government to help educate people, create programs where we can teach people the effects of microplastics, the effects that they have on the bodies, and the effects that it can have in the future as well.
Thank you.
Great. Ernesto?
Yes.
We've got about a minute left.
Okay, Rhea, let me see the prototype that you have.
Yeah, I have two prototypes, the cone and the cylinder, but I think the cylinder is the better one. And here's like a kind of like a cut version of the cylinder. So what it looks like in the inside. So it has 4 layers of essentially this inside of there.
Okay, one question. Those are the filters. So basically you are missing one part. That is the shell that will be having that filter inside. So the product itself, what would be that filter, or what would be the form or the final form of that product that you will be selling?
Okay, so this is one of the prototypes that I could be selling. So this gets essentially hung on the faucet, and the whole outside layer itself is actually coconut fiber, and inside is this with the activated charcoal. So this is all just coconut, and this is one of the final prototypes just for the faucet itself. For water bottles, I would like to kind of implement this kind of system where it's just slide in there, and when you're drinking it, it's actively, and when you're putting the water in, it's actively filtering the microplastics. And I do want to kind of develop like a pellet form, like or like a K-cup, those for the coffee filter, for the coffee. So I want to develop those for other applications as well. And it really depends on the application for what the filter design may look like.
Okay.
You are in mute, Chris.
Sorry, thank you. I muted myself instead of unmuting. We are out of time. And so we're going to say thank you very much to Rhea. Great presentation. Thank you so much for all those answers.